So I'm presenting a couple of work that I've done on making parquet dataset. I know that it's a format that has a lot of interest, so I thought of presenting this. This is work I've been doing at Hui and NCAR. And so the motivation for this is that we can imagine someone wanting to analyze data from the Northwest Atlantic, and they know that Spray Data, GloDAP, Argo are some databases that offer data for them accessible. But if they want to read them, they usually need to write different steps for each of the data sets, like to ingest them in their working environment. And this presents some challenges in terms that, for example, in the case of Argo, we need to process one set of files per floats. We have CSV and SCDF files or mixed up different variable names. And so there's a lot of handling of the data that goes in there. And so if we are starting off with that, we have a couple of bottlenecks, both knowledge related and also technological in terms of performance. And so we would like to make this grad student life easier. Another motivation is Crocodile, which is a project that I'm actually financed by, that is a collaboration with NCAR, whose goal is to reduce the technological burden associated with new regional model configurations. And to give it a brief overview, again, we're always focusing on Northwest Atlantic, but in this case, we can look at anywhere, of course. And the goal of the project is to offer repeatable workflows when it comes to ocean modeling. And so to analyze the ocean state, we usually have a model, data simulation that interact, and they both need observations. And of course, I'm focusing on the observation side. And so the solution to this is Crocolake, which is this data set in Parquet. And we want it to have to be uniform across sources, quality controlled, user and cloud friendly, and program language agnostic. And that's why we have used Crocolake. We have good interfaces with Python, MATLAB, Julia, also JavaScript. The development, the environment around it is quite good, and is faster than other tabular formats, and is cloud optimized for several tools on AWS, for example. What is the advantage of Parquet over CSV? If someone is not very familiar with it, Parquet is column-based storage. And so this means, and it has an index, which is very important. So we can see the index as like the metadata as index of a book, and each column as a chapter of the book where we have the data. And so if we need to read, in this case, the fifth data point of the chlorophyll, we look at the index where the chlorophyll chapter is or column is, and we can just keep all the other columns and go straight there and read that in. This is different from CSV, for example, where we would have to read every row until we would have reached that point. In terms of data products that we offer, there are six total, because there are physical and biogeochemical variables. For Argo data, we have both filtered, QC filtered and non-QC filtered data, while for Crocodile is a merge of Argo and at the moment GloDAP and Spray Gliders datasets. More datasets will come. And for this, we only offer a filtered version. And we have tools to access this data, both in Python, MATLAB, Julia is coming soon, and possibly R. And a quick example for the performance. In this case, the goal was to load 1 year of data, of adjusted data from the Argo BGC datasets in this yellow area that you see on the map. And this is the performance that they got all. So when I say on disk, everything is on my machine, both the data and the code. And Python was quite fast, as it took around a few seconds. Julian and MATLAB takes longer. I'm in touch with MATLAB, like this, the coders at MATLAB, the engineers at MATLAB to improve this. Over the cloud was also quite fast. So in this case, I'm running a notebook from my machine, but I'm accessing the data on AWS S3. And that's also quite fast compared in particular to other tools that are available in the community. Although these are still quite fast if you need a very small data set. And I'm wrapping up. So how does it look like for the grad student now? It's just a couple of lines of codes. So a couple to define the filters, another couple to load the data sets, a few seconds to load it. MATLAB is very similar. And then in this case, we have one pandas data frame with all the different data sets and the variables that are uniform across data sets. This is the nice picture once I load the data and I can show the temperatures from different data sets, and that's it. I will leave the final slide here.